Hello to you all, welcome to the channel. Today we will be interested in a famous integral known as the Dirichlet integral, named after the German mathematician Peter Gustav Lejeune Dirichlet, who used it in the proof of the convergence of Fourier series and in his proof of the central limit theorem. So it's a very important integral since these are extremely important results. Let's start. We will use the Feynman trick, and in this method we usually start with defining a new function, which is an integral depending on a parameter. We can see that if we plug in y equals to 0, we get our integral. So, if we find a nice expression for fy, our job is done. Now, we are going to use Leibniz rule for differentiation under the integral sign, which states that under some conditions we can change the order of integral and derivative. Let's apply this on our function. This will give us that the derivative will equal the integral of the derivative in y. And after simplifying, we will get the following. Let's copy this here for the moment. We can see that the left-hand side is an integral that depends on the sine function and the exponential function. And as everyone knows, we usually integrate this by parts twice, and we find a simple equation that we can solve. Now, this will give us that the derivative is equal to minus 1 over y squared plus 1. And after integration, we get that fy is equal to c minus arctangent of y. C here is of course a constant, which we need to find to get the complete expression of fy. Now, we can see that by letting y tend to plus infinity, the function tends to 0. That means that the limit of c minus arctangent y tends to 0. So c is actually the limit of arctangent as y tends to plus infinity, which is, as we know, pi over 2. Returning to our function, that means that our integral has the following form. And as we stated in the start of the video, if we let y to be 0, we get that the Dirichlet integral is equal to pi over 2. I hope it was clear and that you enjoyed it. I will be posting more on integrals and differential equations and math in general. Like, subscribe, and comment. See you the next time.